Okay, here we are, 2.4b, college algebra. We're continuing with quadratic functions, and I'm going to just give you one. Here we are, f of x equals a times the quantity x minus h, the quantity squared, plus k. There's the form that we're going to look at right now. Now let's actually come up with one. Let's do g of x equals negative 3 times the quantity x plus 5 quantity squared plus 7. Okay, so there's an equation written in this form. So let's see what kind of information we can get out of this. First thing is, what is the vertex? The vertex is HK. Okay, so the vertex here is, we look and see what the H is. Okay, the H is a 5, and the K is a 7. Now this is the key thing here. Look at the formula, x minus h. This says x plus 5. So before we go any further, we need to rewrite this formula correctly so it reflects that. Negative 3 times x minus negative 5 squared plus 7. So see, this has a negative, so this has to have a negative, so we had to change that to a negative 5 so that it's x plus 5. Okay? That is very, very important because the h here is not a 5 because it's not in the right format. This is a plus, it has to be a minus. The h is actually negative 5. The k is 7 because this has got a plus right here, and this is a plus here. So this number, as long as there's a plus there, will be okay. Okay. If this were a negative 7, you would have to write it as plus negative 7. Okay, so that you knew that the k part of it is going to be a negative 7. All right, so this is what we're going to look at. We don't even need that anymore because we changed this to negative negative in order to replace that positive. So there's my vertex. What else do I know? My axis of symmetry is, like I said before, your axis of symmetry is always your h, or your x value. So it's negative 5. Okay? And our max or min, does it have a max or a min? Well, whether it has a max or a min is always dependent on the sign here. If this sign is a negative, okay, if this is a negative, then we have a maximum value. If it is a positive, it has a minimum value because it opens up. So when this is negative, we have a maximum value. And the maximum value then will be this, will be the y value of our vertex. Right there. Okay? That ends up being our maximum value. All right, so given that bit of information, it's not really too terribly hard to graph this thing. All right, so let's write what we have. We have a vertex of negative 5, positive 7. So there's our vertex. We know we have an axis of symmetry. And we know that it maxes out right there, so we know that it's going to go like that. We just don't know where those points are. So we have that bit of information right now. And in order to find other points here, we take this equation, our original equation, we stick a number in here for x, and it'll spit out a y. Okay, so let's do that. Let's take and put in an x and see what we get for a y. So let's put a 0 in here. Or no, yeah, let's put a 0 in here. And let's see what happens. So we have g of x equals negative 3 times 0 plus 5 squared plus 7. So g of x equals negative 3 times 25 plus 7. So we get negative 75 plus 7, which would be negative 68 for our y value. That's kind of a big number. That's not going to be very helpful to us, is it? That when x is 0, y is negative 68. It's way down here somewhere. So we need to find a number closer to our axis of symmetry so we can get some numbers that are up here. So what I'm going to have to do is see if I can do that. So I'm going to go g of x, and let's do negative 3. X is negative 3. And let's see what we get for our y value, or our g of x value here. 2, 4. That's a little better, but it's still pretty big. That's negative 12 plus 7, which is going to be negative, 5? All right, so let's do that. Let's graph negative 3, negative 5. Okay, so there's one of our points. Now, one of the things you need to understand here, our axis of symmetry means that if there's a point here, 2 places over here, there's also a point 2 places over this way. Okay, so every point we find on one side, we can reflect across there to make another point there, giving us a second point. So every time we find one point, we're actually given a second point. Notice, this number 3 is, well, it's not a huge number bigger than 0, but it is a number that makes this not very stretchy. It makes it like that. Okay, now what would happen is if this was a bigger number than 3, our graph would be narrower. If this was a smaller number, closer to 0, it would be stretched way out here. Okay? All right, so let's do another one, and this will be example 1. But before I do that, I do want to make a couple comments here. Look where this is. Okay? If this were over in the x squared, remember how I said our base or our foundation or whatever was f of x equals x squared, and we just did a whole bunch to the x squared. We added 5, we multiplied it by negative 3, we added 7. So it went from this basic place of here, flipped upside down because of the negative, moved over negative 5, moved up a positive 7, and is narrower because of the negative 3. Okay, so that's what happens, is it shifted, moved up, and reflected across the x-axis and gave us that. So you don't have to know all of that. If you follow this stuff here, it'll automatically go to the right place, and you don't have to worry about shifting it and doing all that stuff. But just wanted to kind of share with you what was going on there. And I don't know why I like this stuff. It's just maybe because it makes sense to me and it works. So anyway, I'm going to get rid of all of this junk, and we are going to do another one. So let's move that up here, because we're not going to graph. Well, in fact, let's move it out of here for right now, because we're not going to graph it for a while. And then we can do example 1. All right, so this is going to shut off while I write that down. All right, so this is example 1. This is the form we have to get it into in order to graph it easily. Notice x minus h, the quantity squared. We don't have anything like that. But if you remember, in our last section, we did completing the square. So that's what we're going to do here. We're going to take this, and we're going to complete the square. But we're going to complete the square a little bit different than we have before. Okay? And what we're doing is we need to have our problem in this form right here, which means we need an f of x equals all of this. We don't need a 0, we don't need a y or anything else like we did on completing the square earlier. We want this f of x there. So this is what I'm going to do. I'm going to write f of x. I'm going to write my first term, because this is in the order we want. The second term, I'm going to leave a big space, and then I'm going to put a plus 23 here. All right, so remember in completing the square, one of the things that we did is we took half of this and squared it. Well, that's what we're going to do. We're going to take half of 10 and square it. All right, so one of the things that you've noticed here is that you remember from Algebra 1 is when you add something to one side, you also have to add it to the other to make sure that they remain equal. So if I have a 3 and I say it's equal to 3 and I want to add a 10 here, I also have to add a 10 here to keep them equal. Now they're 13 equals 13, but they're still equal. All right, what if I didn't want to add a 10 to this side? Could I multiply or subtract 10 from this side and have that work? Are these still two equal? Yeah, I added 10 and subtracted 10, so really I added 0, so 3 still equals 3. All right, what I'm trying to do here, and I know that seems silly, but what I'm trying to do here is I'm trying to manipulate this equation to look like this one. I'm not trying to change its value. I'm not trying to solve it. I'm just trying to rearrange things so that it looks like that. So what I'm going to do is, remember the completing the square? I'm trying to get this x minus h, the quantity, squared. And the only way to do that is to complete the square over here to make that happen. So if I do this, x squared plus 10x, half of 10 is 5, square it, get that. This is part of my completing the square, but I can't just add 25 to this problem. So rather than just add 25, I'm going to add it because I need to, but I'm also going to subtract it so that actually I'm doing nothing to it except changing the form. All right, so very, very important to remember here. All right, so now I've got f of x equals x squared plus 10x plus 25. I'm going to put that in parentheses here just to show, that I did something, that I'm going to use that for completing the square. Whoops, 23. Okay? Now, f of x equals square root of x. Bring this sign down. Square root of that. Squared minus 2 from this right there. That is starting to look like this, isn't it? In fact, it does look like that to a certain degree, except this has a plus and that has a minus, which we're going to change that right now. All right, so now this is in exactly the same form as this. The only difference is this has an a out here, a number out here, and the number out here is a 1. Okay, so, but other than that, we have it in that form. Now that we have it in that form, I am going to move stuff out of the way. Okay, and we're going to move this up, and we're going to write the things down that we know here. So, first thing, we know the vertex. Vertex is -5, -2, HK. We know that the axis of symmetry is going to be along -5 because it's always the x value. We know it has a minimum value because the number in front of here is a +1. So whenever you have a positive, you have a minimum value, and that minimum value will always be this number here or the -2. Okay? Okay, so now we can take this original equation here and find a couple other points here. Okay? So let's go ahead and let's go ahead and graph what we have so far, and I will put all this on the next video because I'm running out of time.